in this video, I'm going to show you how to install the BTT Eddy in 7 easy steps. And we might be using the term easy slightly loosely. We want to establish our control. I made sure and took all the slop out of my gantry. I made sure and cleaned my build plate. I made sure and do the screw tilt adjust so that my bed is as level as possible. And I printed a 220 by 220 first layer test to see how well my printer functions with the BLTouch. And these were the results. I'm super happy with these results. It's near perfect. I actually didn't think my printer could print a first layer this well. So at this point, I'm kind of shocked, wondering, should I do this? Let's put those concerns aside and let's get into the install. To install the Eddy, I started by just getting a bracket off of printables. Why design something if you don't need to? So I got this bracket, I printed it, I installed the Eddy on my printer, only to find out that the bracket doesn't give enough clearance between the custom fan ducts that I'm using and the screw heads. I'm gonna have to print my own bracket. So I jump into Onshape and model my own bracket, ensuring that the screws will clear the fan ducts, but making as few modifications as I possibly can, only to find out that this new bracket causes the Eddy to prevent my X in stop from actually connecting. So at this point, I did what any logical human would do. I decided to redesign a completely new hotend that put the Eddy right in front of the nozzle, just like they do it in the stealth burner, right? Because that's what everyone would do at this point. Now, just in case you're interested, the model is linked in the description. But after I got this printed, I did have to go through a couple of revisions because nothing ever seems to work the first time. And I was able to get the Eddy installed. Wait, what? I have to install firmware onto the Eddy? And the answer is yes. Yes, if you're using the Eddy Duo via USB, yes, you have to install firmware on the Eddy. I wasn't expecting this, but after some research, I realized and learned that Klipper actually does it distributes workloads over multiple MCUs, and each MCU needs to be flashed with Klipper. So the MCU in the Eddy does need to be flashed with Klipper, but just as a side note, if you change Klipper versions, you have to flash your firmware. So just keep that in mind because I've already had to do that one. But flashing the firmware isn't that hard. All you need to do is on your Pi, change to the Klipper directory. Make sure you're on the master branch by using git checkout master. Then you're going to run the command that allows you to configure the firmware you're about to compile, which is the make menu config. And this pops up the menu, and you're going to select these options to ensure that it's compiling a firmware compatible with the Eddy's MCU. And now you hit Q to save and exit. Then you're going to run make, which will compile the firmware, and it'll just go line by line telling you which files it's compiling as it compiles them. Once it's done, you'll have the compiled firmware. And to flash it, you have to put the Eddy in boot mode. To put the Eddy in boot mode, there is a little button on top of the Eddy that you have to press that's right next to the cable that you plug in. You don't want to take your Eddy apart to try and do this. Don't do that. But you have to hold that button down while you plug in the USB cable. And if you only have two hands, it's not the easiest of tasks, but it is doable. Now, once you believe you have it in boot mode, you can verify that it's in boot mode by going onto your Raspberry Pi and typing ls USB. And if you see Raspberry Pi RP2 boot device, then you know you've set the Eddy in boot mode. And so now you're ready to run the flash command on the Eddy. All these commands will be listed in the description, so feel free to go down there and check them there. Finally, you want to make sure that you have the serial ID for your Eddy device. So you're going to run the ls device serial by ID command, again, in the description. And this will tell you the actual ID of the device. And you need this for your printer config file. So make sure you save that in Notepad or something like that, because we're going to be using that later. It's at this point that the BTT Eddy documentation actually tells you to do a sudo reboot, which reboots your Raspberry Pi. But we haven't changed any configuration on the Raspberry Pi. So I don't feel like that's necessary. I did it anyway, and I would recommend you do it because it's in the steps of the documentation. But if anybody knows why that's actually necessary or why they're telling you to do that, please comment in the description and tell us why. To update the printer configuration, it's not super challenging. So there are 3 different printer configurations that you can download and use, and so you have to decide which one you want. The first one just uses the Eddy as a probe. You're using a separate device as a Z end stop. The second one uses the Eddy as the probe and the Z end stop. And then the third uses the Eddy as the probe and the Z end stop, but it also has a beta feature for Z offset calibration. This is the one that I used, and if I did it again, I'm not sure I would. I think I'd go with option 2 because, well, we'll come back to that, okay? So select which option you want. Again, I went with option 3, but whichever option you choose, all you want to do is copy all the contents of that file and then put it in your printer config file. Make note of where you put it because you don't want to put it below the section, the save config section. So make sure you put it above that. But find a good spot to put it and drop it in there where it'll kind of stick all together. What I did is I scrolled to the bottom, just above the save config, pasted it there. So it's at the bottom of my file. Now, in this file, there's a couple of things that you're going to want to make sure that you update. One of the things is under the MCU, you want to make sure that you set your serial ID. So that ID that you copied in Notepad, you're going to want to copy that and paste it in that section of the printer config. Next, you want to set your X and Y offsets. If you're using the print head that I linked on printables, your X offset should be 0 and your Y offset should be -28. Then you want to set your mesh min and your mesh max for both your X and your Y. For the min, X, and Y, I just use 15 because it looked like it said use 15 or whatever is greater. And so 15 was the option for me there. I don't know why by default it's set to 10 though. That was confusing to me. Why don't you just by default have it set to 15? For the mesh max, my bed X is 220 and my Y is 190. And the reason I use 190 is because it's essentially 220 minus the 28 millimeters that the Eddy is off the nozzle. I went a little bit extra just to give myself a little bit of wiggle room there. And then finally, you just want to set your home XY position, which because the bed's 220 by 220, it's 110 by 110 for me. And once you do that, you can save and restart and continue on. So if you found the last few steps a little bit challenging, but you've made it to this point, give yourself a pat on the back. You're doing awesome. So in this step, all we have to do is run 2 commands. One command calibrates the drive current, and then we save that to the config. So pretty simple, and both those are in the description. Step 5 is also pretty easy. It's also 2 commands, and we're trying to calibrate the nozzle height here. So one call out I would have to this nozzle height calibration is when you run that first command, it looks like it doesn't do anything, like it's just immediately completes. But what it actually does is it moves the y-axis a little bit, and then it starts moving the gantry, the z-axis up and down, just bouncing that eddy, like testing different currents at different heights. And if you're not paying attention, you won't notice that. And so you may run that first command, then run save config, and it doesn't restart, and you're trying to figure out what's going on. And it takes, I don't know, 10, 15 seconds for this to run. So just run that first command, watch your printer, watch it bounce up and down like that. And then once it's completed, run save config, and it'll reboot. There's just no feedback in the command console to let you know it's doing anything. So it can be a little bit confusing, or at least it was. Step 6 is probably my favorite step, and I think it's the coolest step. You do have to home all accesses after your printer restarts from step 5, but then you get to run the bed rapid scan command, which you get to watch the Eddy for the first time just rip across the bed, scanning and probing the bed and figuring out all the differences and the abnormalities in your bed heights. And so it's just kind of cool to watch. It's the first validation, as it were, that this is actually working and you're getting somewhere. But once you run that first one, you can just run save config after it does that rapid scan, and you're good to go. Now, the next step is the temperature compensation calibration test. And this was extremely frustrating for me because it has you run home all the accesses, then it has you set a timeout, then it has you run this command. And this command asks you to do the paper method, so you get the pop-up, you get the pluses and minuses. So you're moving the head up and down and you're trying to find that sweet spot. And then there's that accept button once you do. I did this test probably 60 times up to this point, and every time I hit accept, I got an invalid internal command, accept. And a Klipper would crash and everything would restart. I couldn't figure out what I had done wrong. I undid everything and started over at least twice. I did tons of researching on the internet. I asked Gemini, I asked ChatGPT, went through every step they recommended, changed so many different things, but nothing seemed to work. Finally, ChatGPT told me, they were like, hey, you know what? I don't actually think this is needed. Run this probe calibration test. And so I ran it and it said, give me the results. I gave it the results and it's like, yeah, your probe is calibrated. You don't need to do this. So there's that. I couldn't get this to work. If you have any idea what was going wrong with mine, let me know. ChatGPT says I'm okay. It seems to be working. So I skipped it. So that would mean this is how to install the BTT Eddy in 6 easy steps? No. Remember how I said I use the third configuration option, which has the beta Z offset features? That didn't work. So Eddy has a section in their guide which tells you how to calibrate Z offset. Fortunately, this isn't very complicated. You just home the printer, place your paper below the nozzle, and then you zero out your Z offset. Don't do this through the baby stepping method. Actually run the command in the G code, have it set the Z axis to 0. Then check and see how that paper moves. And if at that point you need to adjust, use the baby stepping method to adjust it, and then hit the save button in Fluid or Main Cell, whatever you're using, and you should be good to go. You might consider making a couple of changes to your macros. Some of the macros, like one of the things you might consider adding is a rapid scan on your start print macro. But that's it, you're done. Now you have finally installed the BTT Eddy. But does it outperform a BLTouch? Here's my BLTouch, and here is my Eddy result. You be the judge. I personally think it did. Throughout all of these upgrades that I've done, the direct drive extruder, the hot end, and now the Eddy, my main goal was to see if I could get my Ender V2 printing faster than my V3. So at this point I decided, let's race. So I dropped a Benchy, an Orca slicer, and I sent it to my V3. Then I resliced it and sent it to my V2. So I'm giving my V3 a little bit of a head start already. Here's the time difference. Here's the Benchy on V2. And here's the Benchy on my V3. So I think my V3 printed a little bit better in quality, not much. I think I could still improve the banding that I have on the V2 to make it print just as well. I'm super excited at the level of quality I got with both of these printers. And the fact that I've heavily modified my V2 and it's printing faster than my V3, that's just icing on the cake. Now, doing this upgrade absolutely was frustrating at times, but hopefully this video helps you avoid some of the pitfalls that I ran into as I went through this process. Now that I'm done though, I'm super happy with the printer I have. I'm happy with its print speeds. I'm happy with its quality. And I can look at it and say, this is something that I made. And making things, I mean, isn't that why we love this hobby?